Hello everyone, this is a video on IoT, that is Internet of Things. So the overview of IoT. Internet of Things is the internetworking of physical devices, vehicles, buildings and other items embedded with electronics, software, sensors, actuators and network connectivity that enables these objects to collect and exchange data. IoT systems allow users to achieve deeper automation, analysis, and integration within a system. They improve the reach of these areas and their accuracy. IoT exploits recent advances in software, falling hardware prices, and modern attitudes towards technology. Its new and advanced elements bring major changes in the delivery of products, goods and services, and the social and economic and political impact of these changes. Key features of IoT. AI. IoT essentially makes virtually anything smart, meaning it enhances every aspect of life with the power of data collection, artificial intelligence algorithms, and networks. This can mean something as simple as enhancing your refrigerator and cabinet to detect milk and your favorite cereal run low, and then to place an order with your preferred grocer. Connectivity. New enabling technologies for networking and specifically IoT networking mean networks are no longer exclusively tied to major providers. Networks can exist on a much smaller and cheaper scale while still being practical. IoT creates this small network between its system devices. Sensors. IoT loses its distinction without sensors. They act as defining instruments which transform IoT from a standard passive network of devices into an active system capable of real-world integration. Active engagement. Much of today's interaction with connected technology happens through passive engagement. IoT introduces a new paradigm for active content, product, or service engagement. Small devices. Devices, as predicted, have become smaller, cheaper, and more powerful over time. IoT exploits purpose-built small devices to deliver its precision, scalability, and versatility. Advantages of IoT. Improved customer engagement. Current analytics suffer from blind spots and significant flaws in accuracy, and as noted, engagement remains passive. IoT completely transforms this into achieve richer and more effective engagement with audiences. Technology optimization. The same technologies and data which improve the customer experience also improve device use and aid in more potent improvements to technology. IoT unlocks a world of critical functional and field data. Reduced waste. IoT makes areas of improvement clear. Current analytics give us superficial insights, but IoT provides real-world information leading to more effective management of resources. Enhanced data collection. Modern data collection suffers from its limitation and it's designed for passive use. IoT breaks it out of those spaces and places it exactly where humans really want to go to analyze our world. It allows an accurate picture of everything. IoT, like every other thing, has its disadvantages. Security. IoT creates an ecosystem of constantly connected devices communicating over networks. The system offers little control despite any security measures. This leaves users exposed to various kinds of attackers. Privacy. The sophistication of IoT provides substantial personal data in extreme detail without the user's active participation. Complexity. Some find IoT systems complicated in terms of design, deployment, and maintenance given the use of multiple technologies and a large set of new enabling technologies. Flexibility. Many are concerned about the flexibility of an IoT system to integrate easily with another. They worry about finding themselves with several conflicting or locked systems. Compliance. IoT, like any other technology in the realm of business, must comply with regulations. Its complexity makes the issue of compliance seem incredibly challenging, when many consider standard software compliance a battle. Hardware of IoT. The hardware utilized in IoT systems includes devices for remote dashboard, devices for control, servers, a routing or bridge device, and sensors. These devices manage key tasks and functions such as system activation, action specifications, security, communication, and detection to support specific goals and actions. IoT sensors. The most important hardware in IoT might be its sensors. These devices consist of energy modules, power management modules, RF modules, and sensing modules. RF modules manage communications through the signal processing, Wi-Fi, Zigbee, Bluetooth, radio transceiver, duplexer, and PAW. The sensing module manages sensing through assorted active and passive measurement devices. Here is a list of some of the measurement devices used in IoT. Accelerometer, temperature sensors, magnetometers, proximity sensors, gyroscopes, image sensors, acoustic sensors, light sensors, pressure sensors, gas RFID sensors, humidity sensors, microflow sensors. Wearable electronic devices are small devices worn on hand, neck, arms, torso, and feet. So, on head, helmets and glasses can be worn. On neck, jewelry and collars. Arm, watches, wristbands, and rings. Also, clothing and backpacks. Shoes and socks. And these are standard devices. Desktop provides the user with the highest level of control over the system and its settings. The tablet provides access to the key features of the system in a way resembling the desktops and also acts as a remote. The cell phone allows some essential setting modification and also provides remote functionality. And beside it are two pictures. One is of smart glasses that helps us enjoy more of the media and services we value, and one is of smartwatch. Sure. Software addresses its key areas of networking and action through platforms, embedded systems, partner systems, and middleware. These individual and master applications are responsible for data collection, device integration, real-time analytics, and application and process extension within the IoT network. They exploit integration with critical business systems in the execution of related tasks. Data collection. This software manages sensing, measurement, light data filtering, light data security, and aggregation of data. It uses certain protocols to aid sensors in connecting with real-time machine-to-machine networks. Then it collects data from multiple devices and distributes it in accordance with settings. It also works in reverse by distributing data over devices. The system eventually transmits all collected data to a central server. Device integration. Software supporting integration binds all system devices to create the body of the IoT system. It ensures the necessary cooperation and stable networking between devices. These applications are the defining software technology of the IoT network because without them, it is not an IoT system. They manage the various application protocols and limitations of each device to allow communication. Real-time analytics. These applications take data or input from various devices and convert it into viable actions or clear patterns for human analytics. They analyze information based on various settings and designs in order to perform automation-related tasks or provide the data required by industry. Application and process extension. These systems extend the reach of existing systems and software to allow a wider, more effective system. They integrate predefined devices for specific purposes such as allowing certain mobile devices or engineering instruments access. It supports improved productivity and more accurate data collection. Technology and protocols. IoT primarily exploits standard protocols and networking technologies. However, the major enabling technologies and protocols of IoT are RFID, NFC, Low Energy Bluetooth, Low Energy Wireless, Low Energy Radio Protocol, LTE, and Wi-Fi Direct. These technologies support the specific networking functionality needed in an IoT system in contrast to a standard uniform network of common system. Low Energy Bluetooth. This technology supports the low power, long use need of IoT function while exploiting a standard technology with native support across systems. Low Energy Wireless. This technology replaces the most power-hungry aspect of an IoT system. Though sensors and other elements can power down over long periods, communication links, that is wireless, must remain in listening mode. Low energy wireless not only reduces consumption but also extends the life of a device through less use. Radio protocols. Zigbee, Z-Wave, and Thread are radio protocols for creating low-rate private area network. These technologies are low power but offer high throughput unlike many similar options. This increases the power of small local device network without the typical costs. LTE-A or LTE Advanced delivers an important upgrade to LTE technology by increasing not only its coverage but also reducing its latency and raising its throughput. It gives IoT a tremendous power through expanding its range, with its most significant applications being vehicle, UAV, and similar communication. Wi-Fi Direct. Wi-Fi Direct eliminates the need for an access point. It allows peer-to-peer connections with the speed of Wi-Fi, but with lower latency. Wi-Fi Direct eliminates an element of a network that often bogs it down, and it does not compromise on speed or throughput. NFC, Near Field Communication, and RFID, Radio Frequency Identification, provide simple, lower energy and versatile options for identity and access tokens, connecting, bootstrapping, and payments. RFID technology employs two-way radio transmitter receiver to identify and track tags associated with objects. NFC consists of communication protocols for electronic devices, typically a mobile device and a standard device. Application. IoT has applications across all industries and markets. It spans user groups from those who want to reduce energy use in their home to large organizations who want to streamline their operations. It proves not just useful but nearly critical in many industries as technology advances and we move towards the advanced automation imagined in the distant future. Engineering, industry and infrastructure. Applications of IoT in these areas include improving production, marketing, service delivery and safety. IoT provides a strong means of monitoring various processes and real-life transparency creates greater visibility for improvement and opportunities. The deep level of control afforded by IoT allows rapid and more action on these opportunities, which include events like obvious customer needs, non-conforming product, malfunctions in equipment, problems in the distribution network, and many more. Government and safety. IoT applied to government and safety allows improved law enforcement, defense, city planning, and economic management. The technology fills in the current gaps, correct make current flaws, many current flaws, and expands the reach of these efforts. For example, IoT can help city planners give a clear view of the impact of their design, and governments have a better idea of the local economy. Home and office. In our daily lives, IoT provides a personalized experience from the home to the office to the organizations we frequently do business with. This improves our overall satisfaction, enhances productivity, and improves our health and safety. For example, IoT can help us customize our office space to optimize our work. Energy applications. Law enforcement, transport, commercial farming. Let us take an example of commercial farming. Today's sophisticated commercial farms have exploited an advanced technology and biotechnology for quite some time. However, IoT introduces more access to deeper automation and analysis. Much of the commercial farmers, like weather monitors, suffer from a lack of precision and requires human labor in the area of monitoring. Its automation also remains limited. IoT allows operations to remove much of the human intervention in the system function. Farming analysis and monitoring. System detects changes to crop, soil, environment, and more. They optimize standard processes through analysis of large rich data collection. They also prevent health hazards from happening and allow better control. Healthcare and medicine. Emergency care. Development platform and kit. GE Predicts is a software platform for data collection from industrial instruments. It provides a cloud-based PaaS, that is platform as a service, which enables industrial-grade analytics for operations, optimization, and performance management. It connects data, individuals, and equipment in a standard way. GE offers inexpensive development kits consisting of general components and an Intel Edison processor module. Developers have the option of a dual-core board and a Raspberry Pi board. Developers need only provide an IP address, Ethernet connection, power supply, and light programming to set data collection. ThingWorks. It is a platform for the rapid development and deployment of smart connected devices. Its set of integrated IoT development tools support connectivity, analysis, production, and other aspects of IoT development. ThingWorks offers several key tools for building applications. These tools include the Composer, the Mashup Builder, storage, a search engine, collaboration, and connectivity. The Composer provides a modeling environment for design testing. The Mashup Builder delivers easy dashboard building through common components. For example, button, list, wikis, gauges, and etc. Salesforce IoT Cloud is a platform for storing and processing IoT data. It uses the Thunder engine for scalable, real-time event processing. Its collection of application development components known as Lightning power its applications. It gathers data from devices, websites, applications, customers, and partners to trigger actions for real-time responses. Contiki. It is an open-source operating system for IoT that specifically targets small IoT devices with limited memory, power, bandwidth, and processing power. It uses a minimalist design while still packing the common tools of modern operating system. It provides functionality for management of programs, process, resource memory, and communication. Security. Every connected device creates opportunities for attackers. These vulnerabilities are broad even for a single small device. The risks posed include data transfer, device access, malfunctioning devices, and other always on or always connected devices. The main challenges in security remain the security limitations associated with producing low-cost devices and the growing number of devices, which creates more opportunities for attacks. Unpredictable behavior. The sheer volume of deployment devices and the long list of enabling technologies means their behavior in the field can be unpredictable. A specific system may be well designed and within administration control, but there are no guarantees about how it will interact with others. Device similarity. IoT devices are fairly uniform. They utilize the same connection technology and components. If one system or device suffers from a vulnerability, many more have the same issue. Problematic deployment. One of the main goals of IoT remains to replace advanced networks and analytics where they previously could not go. Unfortunately, this creates the problem of physically securing the devices in the storage or easily accessed places. Long device life and expired support. One of the benefits of IoT devices is longevity. However, that long life means they may outlive their device support. Compare this to traditional systems, which typically have support and upgrades long after many have stopped using them. Often devices and abandonware lack the same security hardening of other systems due to the evolution of technology over time. No upgrade support. Many IoT devices, like many mobile and small devices, are not designed to allow upgrades or any modifications. Others offer inconvenient upgrades, which many owners ignore or fail to notice. Poor or no transparency. Many IoT devices fail to provide transparency with regard to their functionality. Users cannot observe or access their processes and are left to assume how devices behave. They have no control over unwanted functions or data collection. Furthermore, when a manufacturer updates the device, it may bring more unwanted functions. No alerts. Another goal of IoT remains to provide its incredible functionality without being obstructive. This reduces the problem of user awareness. Users do not monitor the devices or know when something goes wrong. Security breaches can persist over long periods without detection. Liability. The security flaws of IoT and its ability to perform certain tasks open the door to many associated liability. The three main areas of concern are device malfunction, attacks, and data theft. These issues can result in a wide variety of damages. Device malfunction. IoT introduces a deeper level of automation which can have control over critical systems and systems impacting life and property. When these systems fail or malfunction, this can cause substantial damage. For example, if an IoT furnace control system experiences a glitch, it may fail in an unoccupied home and cause frozen pipes and water damage. This forces organizations to create measures against it. Cyber attacks. IoT devices expose an entire network and anything directly impacted to the risk of attacks. Though those connections deliver powerful integration and productivity, they also create the perfect opportunity for mayhem like a hacked stove or fire safety sprinkler system. The best measures against this address the most vulnerable points and provide custom protections such as monitoring and access privileges. Some of the most effective measures against attacks proves simple. Security. Individuals and organizations should seek hardened devices, meaning those with security integrated in the hardware and firmware. Encryption. This must be implemented by the manufacturer and through user systems. Risk analysis. Organizations and individuals must analyze possible threats in designing their systems or choosing them. Authorization. Devices, whenever possible, must be subject to privilege policies and access methods. Data theft. Data, which is IoT strength and weakness, proves irresistible to many. These individuals have a number of reasons for their interest. The value of personal data to marketing or advertising, identity theft, framing individuals for crimes, stalking, and bizarre sense of satisfaction. Measures used to fight attacks are also effective in managing this threat. So this is all in this video. Thank you.